Okay, so good afternoon, everyone. It is really a great pleasure and honor for me to introduce to you architect Swati Bhargava. Swati Bhargava is a practicing and leading architect based in India and UK. She graduated from the Architectural Association London with distinction in sustainable environmental design. She has worked as an environmental consultant and designer in numerous projects in UK and abroad, ranging from large mixed-use master plans to high-end private housing. She established her architectural practice after completing bachelor's in architecture with honors and securing gold medal from Iojan School of Architecture, India. Her architectural practice has been awarded Certificate of Excellence and numerous other titles like Residential Architecture Firm of the Year. Recently, she was awarded Excellence in Architecture and Design at the House of Commons UK Parliament. Also, Swati has been a visiting faculty and juror in renowned architectural colleges, including her alma mater. Her achievements were published in Forbes magazine. Presently, her architectural practice revolves around concepts pertaining to energy efficiency and passive design techniques. Through her practice, she aims at making people aware about such design methods and educates them to adopt an approach for greener architecture. Also, through her teaching experience, she has emphasized on use of conscious approach to energy and ecological conservation in the design of the built environment. Swati has a very strong base in all the domains of environment, and she is an active secretary of SPACE, that is Society of Public Awareness and Conservation of Environment. So with this, I would like to welcome our esteemed speaker, architect Swati Bhargava. So over to you, Swati.
Thank you, Sheetal, for the introduction. And it's my pleasure to be here presenting my design ideas and philosophy to everybody at the university. Thank you. I would just like to open my presentation. Can you see the presentation?
It is not visible, Swati. Your presentation is not yet visible.
Okay, I'm trying to share my screen.
Yeah, please take your time.
Right. Can you see the presentation now?
Yes, Swati, your presentation is visible.
Okay. So today I'm going to talk about designing the future to predict the future, an urban first approach to planning sustainable neighborhoods. So I'm going to start with the introduction and context, and then talk about the role of urbanization in the global carbon cycle, developing sustainable cities, and I'm going to support this with 4 case studies. The first one will be from Belgium, the 2 from London, which will be my own projects. And then I would be then talking about the Indian context with another case study and the conclusion. According to the UN Environment Programme, the buildings are currently responsible for more than 40% of global energy and one-third of global greenhouse gas emissions, primarily due to the use of fossil fuels like coal and oil that have increased the concentration of atmospheric carbon dioxide. This has brought about an enormous toll on humanity and the environment, from air and water pollution to climate change. Providing a decent life and well being for nearly 10 billion people by 2050 without further compromising the ecological limits of our planet and its benefits is one of the most serious challenges and responsibilities humanity has ever faced. Human activities are causing increasingly amounts of pollution to the extent that this is now recognized as the biggest single risk to human health worldwide. To outpace global warming, we need to change the way we think, from the highest levels of government, policy, and education to the grassroots levels of the common man. Since the construction and infrastructure industry play a vital role in reducing greenhouse gas emissions, there is also a potential for the industry to dramatically reduce carbon emissions. The way forward is to find a model of sustainable urbanism, architecture, and design. Today, 55% of world's population lives in urban areas, a proportion that is expected to increase to 68% by 2050. The projections show that urbanization combined with the overall growth of the world's population could add another 2.5 billion people to urban areas by 2050, with close to 90% of this increase taking place in Asia and Africa. It is further projected that by 2050, India would have added 416 million urban dwellers. Urban areas account for more than 70% of the CO2 emissions from burning fossil fuels. Urban expansion in tropics is responsible for 5% of the annual emissions from the land use change. Predictions of the future trajectories of the global carbon cycle will require a much better understanding of how urban development affects the carbon cycle over the long term. The emission trends in selected countries are illustrated here. Since the beginning of industrial revolution up to the 1970s, in the last 220 years, the group of countries had emitted 910 gigatons of emissions, while just in the last 40 years, that is from 1970 to 210, the emissions have been above 1,090 gigatons. This growth is despite the presence of a wide array of multilateral institutions as well as national policies aimed at mitigation. The richest 10% of the population emits 50% of the total emissions. Here we can see India has an upward rising trend towards the carbon emissions, while on the total contrary, we see the European Union and the UK, which is on a constant decline. The European Union and the UK both have pledged to reduce the carbon emissions to zero by 2050. This reduction in carbon emissions is critical in reducing the effects of climate change and maintaining a global temperature increase of less than 2 degrees. The Europe has seen a fall in carbon emissions of 22% between the years 1990 and 2017, and the UK has seen a reduction of 44% between the years 1990 and 2018. Big investments in renewable technologies such as onshore and offshore wind farms alongside bioenergy have led to significant carbon savings. Although these figures represent a significant contribution to reducing carbon emissions, the rate of reduction is not sufficient to achieve net zero carbon emissions by 2050. To meet this goal, the performance and efficiency of renewable technologies will need to improve, and the cost of these technologies will need to reduce. The burden of reducing carbon emissions does not solely rely on advancement of technological solutions. The human element needs to be considered and addressed, and individual people need to understand their role in mitigating carbon emissions. Talking about the role of the individual, anthropogenic climate change is the cumulative effect of all human decisions made over the last 200 years. Consequently, the potential impact of small changes in behavior and lifestyle choices in the future can accumulate to a large overall reduction in carbon emissions. For example, it is estimated that becoming car free could save at least 1 ton of carbon dioxide per capita per annum, and that eating a plant based diet could reduce carbon equivalent emissions by up to 1.6 tons per capita per annum. Behavioral change will be instrumental in achieving net zero carbon emissions, and this has to be driven by education and engagement to empower individuals to take control of future change within their local communities. This diagram here illustrates how a healthy planet contributes directly to healthier people by encouraging healthier lifestyles. Environmental degradation increases the burden of disease through exposure to harmful pollutants, as well as reduced access to the ecosystem contributions from nature. Now we move to the parameters that play a crucial role in development of sustainable cities and communities. The most important being optimization of concreting to non-concreting and vertical to horizontal expansion of urban area. According to WHO, the bare minimum space requirements per person should be 9 meters square and ideal being 50 meters square per person. The ideal proportion for concrete surfaces to be 60% with 40% open spaces. Poorly planned, crammed neighborhoods where the standard aspect ratios are not followed can lead to disturbed patterns of wind and natural ventilation and extremely narrow street canyons. The next important things to talk about would be albedo effect and the urban heat island effect. Albedo refers to the ratio of incoming to outgoing solar radiations. Higher albedo reduce atmospheric temperature. Use of solar reflective urban surfaces like white roof and light colored pavements can increase the albedo of an urban area by about zero point 0.1. Urban heat islands occur when cities replace natural land cover with dense concentrations of pavements, buildings, and other surfaces that absorb and retain heat. This effect increases energy cost, for example, air conditioning cost, and also increases air pollution levels and heat-related illness and mortality. So we move to our first case study, which is from a small community called Roselair, situated in Belgium. And this represents a methodology utilizing an urban first approach, which champions the role of urban design to deliver a widespread change. This methodology begins with separate analysis of existing carbon emissions, energy use, and the urban form. As we see on the top, these three parameters, they were noted down and analyzed in great detail alongside societal and contextual considerations. These investigations were driven by guided tours around the city, insights provided by local residents, and conversations with local stakeholders and city leaders. Through detailed conversation with the municipality, the energy use and resulting carbon footprint of the city was calculated. The diagram on the right represents the carbon footprint of Roselair. Each square represents 10 hectares of forest land, total area being 30,000 hectares. In collaboration with the stakeholders, a number of urban interventions were developed with a focus on providing relevant infrastructures to facilitate walking and cycling to and fro the city in order to minimize the car use, to increase the density of the neighborhood, to create a defined neighborhood center in order to provide both public open space and to provide opportunities for local businesses and to address the periodic flooding of the adjacent culvert. So there was this culvert which was very narrow and it offered very little capacity to deal with the peak rainfall. Due to the lack of green space in the neighborhood, the surface runoff was also very high. Therefore, it was proposed to widen the culvert and create an elevated walkway along one side to create a nature walk to and from the city. The neighborhood was also in desperate need of a direct route towards the city to greatly reduce the number of needless car journeys taken. This route could be used by those walking or cycling and was covered by a canopy on the top to make it usable regardless of the weather. The canopy also used to grow food and electricity for the local neighborhood. Many of the properties in the neighborhood benefited from the flat roofs, which offer potential opportunities for other rooftop farms. The idea was then further developed with the assistance of carbon accounting and urban energy systems to improve the carbon mitigation at each intervention. The carbon mitigation for each energy intervention was then calculated and tabulated to give an overall idea of how each intervention was was helpful in reducing the carbon emissions for this uh, development. The energy production plan was also altered and it included two rings of photovoltaic panels along the highways, a ring of wind turbines, and 300% electric communities in addition to the rooftop and ground-based photovoltaic panels. Both the urban and energy interventions proposed have varying impacts when considering the reductions in carbon emissions. It also helped the municipalities to determine which interventions would have the largest impact and which should be prioritized. For example, the building envelope improvements or by improving the thermal performance of building skins would be 15 times greater than those provided by the savings of increased recycling, LED lights, and electric buses. Overall, it is a holistic approach to design future zero carbon communities that focus on the multifaceted drivers of society, environment, ecology, and economy that helped drive the first explorations into the eco city design. Now, moving on to the next case study. Uh, this is this is based in the London, the south of London. There is a place called Peckham, and the project is called Peckham Mixed Use Development. So the challenge for this
Very
project was to create a community which would be sustainable, self-contained, a mixed-use community. Based on the project brief, various massing configurations were worked upon, and various studies were conducted on the following parameters. After coming with the basic configurations for this development, the shadow analysis was conducted during the 3 different parts of the year. The solar analysis was done to study the impact of radiations on the horizontal and vertical surfaces of the development. The wind analysis was conducted, and the block to the south was tilted in a way that it let the natural ventilation through the development as well as through the individual units in this development. The thermal comfort indices were calculated for a typical hot week and a typical cold week to study the ambient temperatures for the outdoor spaces. Since this community had to have family with kids, different activities were planned based on the ambient temperatures that would be achieved during the different parts of the year. Any areas during the hot week which would be above 25 degrees were proposed with vegetation and water features. And in the end, this is the site plan that was derived based on all of the above studies. Coming to the typical layout for the different typologies here. So the south and the west blocks, they were the terrace houses with 3 bedrooms. The whole idea was to create sustainable small units, which would which would in turn then contribute to the bigger community being a self-sustained community. So starting with the section, the first concern was to enable natural ventilation throughout the units. The slopes were all positioned towards the south in a way so that the photovoltaic panels would be placed on top, which would contribute to the energy um, generation of the project. All the rainwater collection from the roof was channelized in a way that would go into the water tank with a pump. This water was being pumped on a daily basis to the high level water tank, through which all the toilets, the bathrooms, and the kitchens were being given their supplies. And the wastewater from there would be taken to the garden tap. There were these sun spaces towards the south and the west, which were designed in a way that it would let the winter sun to get into the interior of the bedrooms and inhabitable spaces, while the summer sun would stay out so as not to cause any overheating to the project. The use of thermal mass enabled the avoiding of overheating into the project. So that is a typical section for the terrace houses. Similar concepts were applied throughout the other units. A space of 1.5 meter by 2 meter, a convertible space was given in each of the units, which would have adaptive flexibility options for the occupants. The idea was to have this space perform in different ways in order to have the occupant comfort. It could be a balcony with night shutters for the night ventilation. It could double up as internal space with night shutters for the summer ventilation, or for the winters, it could just be a sun space and provide the required warmth during the cold winter months. For the units facing the north side, the provision for north light was given so that the lighting could be achieved in a good way. The PV panels, the flat roofs were given for the occupants to grow their own food. Different strategies for summer and winters were proposed. So the same space or the same kind of sun shading would double up as a summer shading, a sun shading device, as well as for the winters, it could act as a conservatory for the units, and the option for adaptability offer different flexible space options according to the season. For example, this shading device, these are sliding louvers to prevent glare when the winter sun really gets low, and the night shutters for the bedrooms and the curtain and blinds in the living rooms would act as different adaptable options for the occupants. Also, the daylight analysis was conducted for each unit in order to optimize the size of the windows according to the different orientations. The idea was to provide adequate lighting levels throughout the space so that the consumption of electricity could be minimized, and at the same time, the glare would be avoided in the peak summer seasons. Further, the thermal performance studies were conducted for various parts of the project. Here, the green band, it indicates the thermal comfort for the occupants. So the idea would be to have the ambient temperature of the spaces to fall within these thermal comfort zones. And to achieve that, all the activities were according to the time, and the use of appliances were calculated, and everything was put into simulations to achieve a projection of what the thermal performance of the building would look like in the entire year. Different adaptable options for the peak overheating periods, for the summer periods, and the winter periods were proposed. And this is how the energy consumption projections were calculated for each unit. After knowing the energy consumptions for the entire community, the calculations for the solar photovoltaic panels were calculated in a way that the annual electricity generation would be equal to the annual energy consumption, and the number of square feet that was required to place the photovoltaic units was calculated so that the entire community wouldn't require any external electricity. It would always generate its own electricity, being self-reliant. And this is, there were further researches done for the material. The cladding materials were proposed in a way so that the carbon miles would be minimum. Uh, so it would have the minimum carbon footprint during the stage of construction and post-construction. Moving on to the next case study, this is another study that is one of our own company projects in London. So the project is called Heath House. It is a grade 2 listed building, and it dates back to 200 years of history, and it has very interesting story about the Second World War, where a part of it was bombed down. So my company in London was involved in the refurbishment and construction of the new wing towards the side. And the clients had approached us with a very excessively mechanically ventilated proposal from the engineers. So the client had proposed us to come up with a thermal analysis for this project. So we conducted a series of simulations. We developed a thermal model. The whole idea was to calculate the heating and the cooling loads for this property, so that we could analyze if the amount of engineering that was going into the project was required or not. And in the end, all the heating and cooling loads were calculated for each space. And natural ventilation strategies were proposed. And towards the end, it was found that the engineers had overly prescribed the mechanical systems. They had proposed a lot of air conditioning in a climate like London. And it was found that towards the end, just by the use of simple natural ventilation techniques and adding few more passive design elements to the building skin, there would be massive reductions in these in the installation as well as the running cost. And towards the end, the client was able, based on these studies, the client was able to save more than Indian worth rupees of 5 crores just on the equipment cost with this project. So the whole idea about doing these kind of studies is when we are able to sort out the carbon emissions at micro level, it can really lead to good results at community level. And from community level, we take it to the urban level. So all begins with the small little inputs that we as architects are able to make to these buildings and projects. Now, after we spoke about the Europe and the UK, coming back to the Indian context, India's per capita consumption is one of the lowest in the world. And this is where we have a hidden opportunity. If we draw energy from clean renewable resources, the amount of land required to place the solar panels would be roughly 10,000 square meters, or 2.2% of India's wasteland. If we calculate the amount of area that we need to place solar panels to have clean renewable energy, we are only talking about 0.1% of India's land mass. Also, based on the country's annual rainfall, proper storage, and utilization of water, rainwater can result in availability of 2,000 liters of water per day per person. It is evident that we have enough land, water, and energy resources in abundance. Despite that, Indian cities have the poorest air quality and are facing acute shortage of water and energy. Now I'm going to talk about another case study, which is all about using the passive design techniques in the tropical climates for a site in Jaipur. And through this project, I would like to talk about how massive reductions in energy consumption were achieved. This site is located in Jaipur. Jaipur is a typically hot and dry climate zone area, and the project was about getting back the vernacular styles, the elements of jalis and courtyards, the traditional elements that have been long forgotten. So these elements of jalis and courtyards, there was this whole research that was conducted. The purpose being quantifying the environmental performance of the screens and courtyards to achieve thermal comfort and lower energy and lower carbon emissions. So models for different jali sizes were developed, and the parameters were studied on the basis of the size of perforation and the air perforation percentage. Through physical models, different values were taken, and the best the best scenario for the jolly size was taken to be 80 millimeters by 80 millimeters. Now this was tested at different sun angles at different times of the day. And based on these calculations, an optimum size for the jolly screen was taken. Daylight analysis enables the space to come up with the optimum size for the windows. So let us say a fully glazed facade with 100% wall to window ratio, and then narrowing it down to different percentages, and then addition of screens with 40% perforations, 50%, and 60% perforations were tested. So these daylight analyses were done with the south and the west orientation for a climate for a tropical climate in India. Based on these studies, the best scenario for the lighting was calculated, which was screens with 60% perforations with a 35% window to wall ratio. Then the daylighting analyses were done for the north and the east orientations. So the azimuth angles were calculated at different parts of the time of the day, for example, at 9 a.m. in the morning and 6 p.m. in the evening. And these kind of louvers were designed for the other two orientations. So this enabled us to know what window sizes, what jali patterns, and what kind of sun shading devices would work best in order to provide visual and thermal comfort for the occupants. Further, a typical size for the rectangle was taken with a 1:2 ratio. And then a central courtyard was carved out after having a 12-meter passive zone. So a passive zone is a dimension through which the natural light can penetrate through. Since this was supposed to be a workspace project, and hence the areas were considered according to that, the space was divided into smaller courtyards. Based on the solar studies, the various azimuth angles were calculated for different times of the day for 4 p.m., 12 noon, and 9 a.m. The idea was to come up with a courtyard design that would promote the maximum shading so that the courtyard would be used for various indoor activities like informal meetings, outdoor library, cafeteria, recreation, and sitting areas. A shadow analysis was then conducted. with different configurations. And towards the end, these kind of patterns, which promoted the maximum shading, were selected as the final form. The various floors were stacked on top of each other, and perforation in the facade for the airflow were created based on the wind pattern studies. Coming to the final form, so this is what the final form looked like. The basement was dug 3 meters under the final floor level, the ground level, and water bodies were introduced in order to lower the ambient ground temperatures. And according to the set of studies conducted, it was found that the basement temperatures always remain 25 degrees, even when the outdoors would soar higher than 40 degrees centigrade. The final form took the shape of a rectangle with these perforations. So they were vertical as well as horizontal perforations, which enabled these breakout spaces where people would find their shaded areas surrounded by greenery, water features, and have functional interactions with a lot of vegetation, cross ventilation, and also the views to the context. Further coming down, the thermal analysis was conducted for a typical unit. So firstly, a base case was considered with a fully glazed facade, which was all glass. And then from there, new interventions were considered into the space so that in the end, we would achieve the ambient temperatures to fall within the comfort zone, which is marked in gray over here. For example, the first option, the base case was for a fully glazed facade. So the temperatures can be seen soaring high like that in blue. If the temperatures were to soar as the indoor temperatures were to go as high as 40 or 41 degrees like that, imagine the project would need to be fully air conditioned, and that would again lead to enormous energy consumptions and in the end carbon emissions. So the next intervention was to have the Jali screens on the south facade. With this intervention, we can see this red line over here, the brown line. There was a drop of ambient temperatures by 6 degrees. The next stage was Jalis on south facade plus the night ventilation. So during the night, ventilation was proposed so that the heat gain throughout the day could be released during the nights. And in the end, the thermal mass was considered like exposed concrete surfaces, which would again help in releasing the heat. So after putting all the four options together, this is what we achieved, the line in red. This was completely within a band of 26 degrees to 32 degrees over here, absolutely within the comfort band with some sort of natural ventilation. So in the end, just by applying these passive design techniques, we saw the temperature difference of 11 degrees falling within the daytime. So this 11 degrees is very important if we need to reduce our mechanical cooling cost for a climate in the tropics. So in the end, we see here how the energy bills, the energy consumption dropped significantly by use of all of these parameters. The cooling loads that were achieved towards the end were 30 kilowatt hour per meter square per year, which is it's almost 1/3 of the benchmarks that are prescribed by BRIHA. Then moving forward, talking about the adaptive strategies. The adaptive strategies, they allowed different configurations for different parts of the year. For example, in a hot period, all the closed Jali screens would provide protection from glare, and also the evaporative cooling on the outer side would help have spaces function without air conditioning. And for the mild periods, the people would just slide the jalis. They would use it more like combine the outdoors to the indoors, making it quite pleasant during the mild periods. The building would then adapt itself during the dew parts of the year. A building that closes itself to the outdoors in a day in the hot period, while in the mild period, it would just open itself to the surroundings. So, in conclusion, after talking about UK and India, everything boils down, narrows down to how we build. Traditional architecture has always been green, as interventions were built around localized or regionalized context. Today, environmentally sensitive architecture is no more a choice or a layer that can be applied to design of a building. Rather, it must be integral to the process of design from concept to completion and to the entire life cycle of the development. So the need of the hour is to implement passive design strategies to create conducive microclimates, which in the end, they contribute to the macroclimates on urban levels. The effort should be made to reduce the perceptible temperature in the hot, dry season, augment wind movement in the humid climates, enable evaporative cooling through use of water bodies and proposing rooftops, shading in hot climates, and maximize solar ingress in cold climates. Orientation of the building and optimization of form, also optimization of the area of concreting to non-concreting, are the fundamental strategies that must be deployed with the aim of maximizing daylight, natural ventilation, at the same time controlling glare, heat ingress, and the use of mechanical methods. Landscape design are also the key tools that play a significant role in creating environmental buffers, facilitating effective microclimates. Greenery makes a great impact, also provides nicer views than concrete or tarred surfaces. If green roofs are not feasible, another approach would be to plant more trees on the site and also at community public spaces. The goal when building green is also to pay special attention to detailing and vernacular methods of construction. Incorporation of local techniques of craft and construction and an inclusive approach to local materials can result in promoting low carbon footprint. Inspired by the traditional methods of construction, such as earthen pot insulation, high thermal mass walls, cooling pots, wind catchers, can impact can impart a distinct identity and character to the building while tackling the affordability aspect of construction. So, as architects, we have a glorious opportunity today to take what we have learned from building with limited resources in the past, over centuries, and also learn from the mistakes and leap into an architecture that is sustainable, not only environmentally, but financially, socially, culturally, and technologically. An architecture that is global, that local to each area. It is imperative that we take few back steps into the past to be able to find solutions for creating an environmentally sustainable future. Thank you.
Thank you, Swati. So now participants can ask questions. Participants, you can ask questions one by one, or you can type your questions in the chat box. Yes, Isha. बोल तू.
Should I read the question?
Hello, ma'am. Ma'am, hello.
Yes, Isha.
Ma'am, I'm from BSc Environmental Science, Bachelor's degree in Honors, final year.
Yeah.
I have a question that after graduation in bachelor's, I'm interested in this architect work. So, what kind of courses would be available for us in this development programs? Like how we can enter in such programs or activities?
Do you want to continue with your master's, did you say, in the environmental sciences?
Yes, ma'am.
Right. So, because you're doing your BSc in environmental sciences, I think there is a whole range of options for you to consider in the masters. There are different masters in sciences, in sustainable studies that you could take up. And this is very much relatable because you're from the environmental science program. There is sustainable environmental design. You could go for a construction management in sustainability. So there are a lot of options these days that you could consider having after completing your final year.
Okay. Thank you, ma'am.
Okay. Yes, Zafara ma'am. Yes, ma'am. You can ask question.
Yes, good afternoon, Madam Swati, Madam.
Good afternoon.
Your talk was very informative and it was very interesting.
Thank you.
And I have a question, ma'am, that in London case study, you discussed about rainwater harvesting in buildings.
Yes.
So as far as I know, in London there is rainfall for around 11 to 15 days.
Uh, in London, it rains nearly 8 to 9 months of the year.
Yeah, and in a month it is around 11 to 15, 20 days, if I'm right.
Yes.
Yeah. So, what will be the storage capacity of the tank in that case to use that same water for domestic purposes?
Right. Right. So if I talk about that unit that I showed in my section, so you saw the different configurations. I discussed, let's say, the terrace housing. So firstly, the surface runoff is calculated based on the surface area that we are considering in our design. And then based on that surface area, the amount of rainfall, the storage capacity, how much water is going to flow through that one roof terrace is calculated. And of course, there are specialists that would come up with the calculations, and all we do is give them the base areas for the runoff and how much storage capacity area we have for the basement and for the top space. But these are technical calculation that can always be done based on what is the roof area for each unit.
Okay, ma'am. And one more question, and it's a personal question. So recently we shifting to a new home. We have large sliding doors which connect hall and so I just need a
Sorry, your
suggestion
voice
on.
is breaking up.
Yeah, am I audible,
Can
ma'am?
you repeat the question? Yeah, your voice is breaking up. Can you repeat the question,
Yeah.
please?
Yeah, ma'am. Actually, it is a personal suggestion and advice that I'm asking you for. That our hall
Okay.
and our gallery is connected with a glass sliding door, and I believe in summers
Okay.
our temperature may rise. So,
Right.
can having a vertical garden in our balcony help us cool down our room?
What orientation are we talking about?
It is southwest.
Okay, so you've got the glass doors in the southwest.
Yes,
And
ma'am.
is the balcony facing the southwest?
Yes, ma'am. Yes, ma'am.
Yes, so I would say that any sort of vegetation wherein the solar radiation gets onto that surface, it could be any water feature, or it could be vegetation. If the solar radiation falls and then reflects into your space, it's going to make a difference. And also, we spoke about the albedo effect in the presentation. Again,
Yes,
if you
ma'am.
have more reflective surfaces in the balcony, be it the walls, be it the floor or your ceiling, if you have light colored pavement material, the flooring material, or the wall finishes, that is also going to make an impact.
Thank you. Thank you so much, ma'am. This will really help. Thank you so much,
And
ma'am.
sorry, did which city is that?
In the same city, Surat.
Okay, and also when you talk about vertical vegetation, if you have any surfaces where you could hang, like jute screens or have clay jalis, and evaporative cooling, if you just put some water on that and let the
Yeah.
cool breeze flow through that wet surface into your space, that's going to make a huge difference. I have tried and tested at one of my projects in hot and dry
Oh,
climates.
that's a great idea, ma'am. And this will be quite innovative and new, I believe. I
Yes.
have never seen such a concept here in Surat. So this
Yeah.
will be really helpful to me. Thank you. Thank you so much, ma'am.
Thanks.
Hello, ma'am. My name is Anjori Kalatkar, and I am from Environmental Science, second year. My question was, what are the upcoming green technologies that have been employed in other developed countries, but it has to be researched more in India?
Right. So, I will give you a link to some of the technologies that I think largely needs to be explored in India. So there is a company called Z Factory. It's a practice, Z Factory in the UK, and what they are doing currently, they are making products. They are designing their own products and launching in the sustainable market. For example, they have the window glass. The window glass itself is a solar panel. You see it as a window, but it is a solar panel. And just by putting those glasses in your windows and your railings and as a skylights, it is doing two jobs: one of a window to allow light in the house, also it is storing the solar energy, and then it is transmitting to the energy plants. So I think this is very innovative, and this is being widely used in the UK at the moment. So concepts like these need to come to India, because we have a lot of opportunity, because we have much more sunlight, solar radiation than all of those cold countries.
Hello, ma'am.
Hi, Akshita.
Hi, ma'am. I am Akshita Shah. I am an environmental engineer, and currently I am doing my Masters of Engineering. And along with that, I am working as an environment officer, and I have about 3 years of experience.
Okay.
So, yes. So I want to ask you that which university in UK can I study, and which course for working in this field in the future?
Right. So the UK offers a number of options when it comes to environmental sciences. Like I studied at the Architectural Association. I studied the sustainable environmental design. I did my master's in architecture from there. UK offers two courses. One is master's in architecture. The other one is which is the MSc course, the Master in Science. And you can look at universities like Oxford Brookes, and then there is UCL. Even the University of Nottingham is good to do any sort of that course. But my experience, I just went to Architectural Association because I think that's one of the best institutes to study sustainable design from.
Okay, ma'am. Thank you.
Sadafara ma'am, do you have any question? You have raised hand. Sadafara ma'am,
Yes.
do you have any question?
Yeah, I have asked.
Yes, you are audible ma'am. Okay, so any more questions from participants? Any more questions, participants?
I can see a question from Jyotsna Pandit. Jyotsna Pandit is saying her question is, does the community encourage collaboration in sustainable urban planning and development? So if you talk about communities, so there are communities across the globe. I showed in my graph how the UK and Europe, they are on a downward trend when it comes to the carbon emissions. And this is the sort of awareness that everybody should be working at, as designers, as urban planners, as architects, and even as individuals. This is the kind of awareness that we need to bring across communities, and this can only happen when at micro as well as macro levels we have such programs and informative sessions. Every person can make a difference. And like I discussed about the Roselaire project in Belgium, that's how the whole community came together, right from the government level to the individual level. And they were able to really come up with a very promising strategy regarding carbon emission reduction.
So any more questions, participants? You can write your question in the chat option or chat box. So Swati, can you suggest the students and young people as to how they can be leaders in restoring urban environment?
Right. So, as I told you, that there is a capacity for every individual, from individual to a professional to local stakeholders to the governments. At every level, we've got the opportunity, and we have the capacity to act upon all the advanced countries that I spoke about in my talk today. Let's say UK, we talk about EU. They have a very properly managed strategies where they want to see themselves in 2030 and in 2050. So they are working towards the target. If I talk about London, the government is very strict with in terms of policies. Small interventions like simple, here in India, we like to drive our car to every place we want to go. What happens in the UK is they are currently trying to discourage people from driving their own cars. For example, they would put a heavy number on toll taxes just because they don't want you to drive. Because of that, the public transport is being heavily promoted through them. One of the main streets, which is called the Oxford Street and the Regent Street, they are like the lifelines of London. They are planning on completely cutting off the car traffic. All they are going to do is to develop it like a pedestrian and a cycling route with a lot of greenery, because that's the center, the hub, the commercial hub. So things like that. Also, they have made low carbon emission zones throughout the country. So if your car produces the carbon emission beyond a certain level, the moment you enter that zone, you will be charged a toll tax for being a high emission vehicle. So, things like these, they really help each and every person understand where we are trying to lead our communities toward. And I consider a lot of architects might be listening to me, or designers or planners. Again, the reason I spoke about individual buildings and individual elements today is because if each of our unit, be it apartment, be it a house, be it our office, if we are doing our best to to do our bit in achieving low energy, low consumption unit, which produces less pollution, less carbon emissions, we are doing our bit towards reducing the entire carbon footprint on the earth, which is going to pay us and our future generations in the coming years. Any more questions?
Participant, one question. So I guess there are no more questions. Thank you, Swati.
Thank you
Now
all.
I
I'm
would
going
like
to,
yes,
yeah,
Swati,
sorry.
please.
I'm just going to leave my email address in the chat. If anyone has questions, they are free to contact me on email.
Thank you, Swati. Participants, you can note the email ID if you have any question or if you want any guidance from Swati. You can definitely mail her. So now I would like to request our principal of School of Sciences, PP Savani University, Dr. Anish Kumar Sharma, to present vote of thanks. Sir, please.
Okay. Thank you, Dr. Sheetal, and good afternoon to all. I, Dr. Anish Sharma, Principal, School of Science, PP Savani University, on the behalf of my university, express sincere thanks to our expert speaker, architect Swati Bhargava, for conduction of such a wonderful and informative webinar on this topic, which is pertaining to sustainable neighborhoods. I thank her for sharing her knowledge with our students as well as all the participants. And I hope that they have enjoyed the session and they have enhanced their knowledge regarding sustainability and its importance. Thank you, Dr. Swati. And
Thank
I
you.
hope further also in near future also we will have more sessions from you in this topic, regarding this topic. Thank you again.
Thank you. My pleasure.
Over to you, Dr. Sheetal.
Yes. Thank you, Swati. Thank you very much. The session was very informative, insightful. Thank you for inspiring us and guiding our students and all the participants. Thank you very much. Thank you for taking out time for us.
Thank you.
Okay. So, participants, I'm sending you feedback link. Kindly fill it before leaving.